G'day team, Craig here from Imagine Homes with another instalment in our series on turning your sustainable home dream into reality. Today we're going to look at solar passive design, and I'll be discussing this as it relates to Australia and the rest of us living in the Southern Hemisphere. If you're watching this from the Northern Hemisphere, you simply have to substitute north with south and come to terms with the fact that the best and hardest rugby league and rugby union is played in the Southern Hemisphere. Solar passive design refers to the use of the sun's energy for the heating and cooling of living spaces by managing exposure to the sun. When sunlight strikes a building, the building materials can reflect, transmit or absorb the solar radiation. Orientation, material selection, glazing, ventilation and insulation all have a part to play in maximising the effects of solar passive design. A passively designed home makes the most of natural heating and cooling methods to keep its occupants comfortable all year round. Orientation, spatial zoning, thermal mass, ventilation, insulation, shading and glazing are the 7 core components of passive design. But home orientation is particularly important. It is important for the building to be correctly oriented to allow the sun to flood in during the cold season and shut it out when it's hot. The other 6 principles of passive design can then be balanced to create homes that require minimal active heating or cooling. Good orientation from a passive design perspective generally means locating the living areas on the north side of the house. The key is having glazing with clear access to sunlight, especially in midwinter. Our first consideration is to design for the climate. Different climate needs different houses. So in Australia alone we have more than 80 climate zones. That means you require the design and delivery of a home that is appropriate for climate and adapted to both your needs and the microclimate of your site. Design is more than just the structural components of the building, but the balance of light, heat and insulation to achieve the best balance of utility and cost, both construction and running. Something project builders can't achieve with standardised designs. For example, if you're living in an environment with hot summers, like here in Australia, the western wall of the home should have no glazing or limited glazing. The home should be further protected from the effect of heat by situating maybe the garage on the west of the home. If you must have glazing to the west, you could, for example, add a deciduous tree or a vine-covered pergola to allow light in during winter but provide protection during summer. So now let's look more closely at the construction elements as opposed to orientation. Firstly, the overall construction technique. Traditional Australian construction standards result in leaky homes, the air changing up to 20 times in an hour. This leakage creates drafts and results in increased heating and cooling costs. Sealing leaks post-construction is difficult and costly. This is a balance, because in modern conditions some leakage is acceptable, even encouraged, as sealing the home too well can result in damp conditions due to condensation. In severe cold conditions, the home is sealed as best as possible and the damp conditions addressed with an air heat exchange system. If you live in these conditions, I'm sure you're aware of the requirements, so I won't go any further today. Next is insulation. Insulation provides a barrier to heat passing in and out of the house. In many cases, good design and good insulation can provide a dwelling that requires limited or no heating or cooling. In winter, once your home has been heated to a comfortable level, it will stay that way with less energy input than an uninsulated home. Insulation and the exclusion of drafts can result in a saving of up to 30% on your energy bills. The next consideration is glazing. Windows and glazed doors can leak considerable heat, both in and out. Good design will determine the optimum glazing requirement. Consider the benefits of double glazing, but there is no need to go overboard chasing energy rating stars. Balance the cost of the windows with the projected savings over time to find the right balance. I'll cover glazing in more detail in a later video. Glazing must be considered in concert with thermal mass in the design of your home. Thermal mass is where you store or release heat to, depending on the season. In winter, we allow sunlight to flood the interior of the home. The use of masonry or water allows you to collect and store this free heat to be released back into the home as the temperature drops. Consider sunlight coming through the window and hitting a carpeted timber floor that is raised off the ground on stumps. There's no thermal mass, so the heat is not stored. It simply warms the immediate environment and is then lost. If the floor was concrete, however, and was insulated from the ground with dark tiles, it would absorb the heat and store it for release in the late afternoon or evening. In summer, we understand the solar variance, that is, the sun is higher in the sky as it traverses from east to west. So we work with this by providing eaves to prevent the sun spilling through the glazing. This keeps the thermal mass cool. It wants heat, so it will absorb it from you and the internal environment, making you feel cool. The sun's energy is not lost here though. Using free electrical energy converted from the sun by a photovoltaic array system, you can use the air conditioning to cool the thermal mass during the day while you're at work. You then return to a cool and inviting home due to the free power and thermal mass. This process is known as load transfer and is something I'll discuss in a later video as well. Suffice to say that 10 AM to 2 PM is the new off-peak electrical load. Only it's better because it's free. So in summary, solar passive design is primarily about designing the home to maximise the use of the available solar characteristics. We do this in order to minimise the ongoing costs, simply maximising the efficiency of the home. Using common sense, we store heat when we need it through a combination of glazing, thermal mass and insulation, and we prevent heat storage when we don't need it by taking advantage of the higher traverse of the sun and the use of PV and battery systems. So how many project homes have you seen with no eaves, windows on the western walls and most of the glazing to the south? There are hundreds built across Australia every week. Be an informed home builder and work with a builder that has some common sense. If you haven't had a chance, you may wish to go to this link and download our free ebook, 7 Things You Must Ask Your Builder Before Designing Your Sustainable Home. Also, if you have any topics that you'd like us to cover in future videos, please let us know in the comments below. And while you're there, don't forget to subscribe and hit the bell so you're notified of future releases. On behalf of Mitch, Sam and I, the team behind Imagine Homes, I wish you all the best in your journey and trust that your home building dreams turn into reality. Cheers.